So the lab we'll be doing tomorrow has essentially two purposes. The most important purpose is to investigate how the microscope works. I kind of talked about that when I showed you how Hooke developed the first microscope, what happens to the light when it goes through the lenses. Okay, that's all kind of important stuff. So the problem we're investigating then is, how does the microscope allow us to see tiny specimens? The other part of this lab is to gain some experience using the microscope and get better at it, so that when we actually have to look at the parts of the cell, we're able to get them focused and we can see them work and all that kind of stuff. Something wrong with it? Oh, okay. That's usually serious. Okay. So those are the two purposes of the lab. Okay, like I say, the problem we're investigating, how does a microscope allow us to see tiny specimens? So we have to identify our manipulated, responding, and controlled variables. In order to fairly determine how the microscope works, we're going to have to look at different things. Okay? Because looking at different things will allow us to see if all things we look at are treated similarly by the microscope. Okay? That is, like, if I put a whole bunch of stuff underneath, does all of it look bigger, kind of thing. Okay? So what will be changing throughout the lab is what we're looking at. Okay? We'll be looking at different specimens throughout the lab. Okay? The specimens we'll be looking at are the letter E, an amoeba, a paramecium, and the euglena. So we'll be getting progressively smaller with each specimen. Okay, so the responding variable then is going to be not just what we see, but we have to be more specific than that. Okay, when we look at something through the microscope, like, what are we seeing? Not so much what do we see, but how does it look? Okay, you need to be a little more specific than how does it look and what do I see. Be specific in terms of predicting how the microscope is going to alter what you're looking at. Okay, controlled variables. The most important controlled variable is your technique. Okay, so I'm giving you one, technique. Essentially, you need to view all of the specimens in a similar way. Okay? That is, they're put under the microscope and you are, looking at them with the scanning power lens, and then maybe not all of them, okay, to low and to high power, depending on how big they are. Okay, you're getting them in focus, you're, that kind of thing. So technique is obviously pretty important. All right, I would also argue that some of your settings on the microscope would need to be the same, for taking pictures of them, okay, stuff like that. Anything that's going to affect what we see and what we record needs to be kept the same. All right, so you can come up with a few there. All right, so for the hypothesis, what three words need to be in the hypothesis? If, and then. What does the if part need to tell me? Okay, yes, the premise. Okay, the if part is about the premise. The premise here is how the microscope works. So should I say in the if part how a microscope works? Yep. Okay, and we talked about that, like I said before, when we were discussing how Hooke's microscope works. So the if part should talk about how a microscope works. So if a microscope works by blah, 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 don't say blah, blah, blah. Okay. The and part describes our experiment. So different specimens are going to be viewed under the microscope. What's the then part of your hypothesis supposed to do? Yeah, predict your results. So what should you talk about in the then part? What are our results for this lab? Yeah, but again, let's be more specific than what we saw. I would say appearance. appearance of the specimens. All right. Your observations, like the procedure is already written out for you, so you're not going to have to do anything with the procedure, but you're going to have observations. Your observations are going to be a lab diagram, right? Lab diagrams have a very specific format. If you vary from that format, your mark will decline significantly. All right, so I'm only doing this to try and save you the agony that I had in university when I didn't follow the format. Okay, if you handed in a lab diagram that was not rigidly following the prescribed format, you just got a 0 on it. Okay, I won't do that to you, but there's only 3 marks for your observation, so you can see how you could get to 0 pretty quickly if you stray from the format. Okay, so format of a lab diagram is like so. This is like my best drawing ever, so I keep it every year to show people. Okay, it's awesome. All right, so here's how a lab drawing goes. Okay, you will have, for you guys, not a drawing, but the picture that you take centered, maybe slightly to the left of center. Okay, on the page, make it as big as you can. You want the picture of the specimen to be as large as possible without getting grainy. Right? Because obviously that's a problem when you start blowing things up, okay, is that they can get grainy. So make sure that it is as big as possible without getting unclear. All right, so you have that. Then in the top right-hand corner is your name and the date. Okay, I'm so proud of this that this diagram is now 8 years old. Okay, but it's such a good drawing. Okay, then you will have labels. Notice all of my labels end in horizontal lines. That is the way they're supposed to end. And notice that they are all to the same side. Right? That is to make sure that the diagram doesn't start to look cluttered or busy. All the labels should go to the same side. So when you put your picture in, make sure it's a little off to the left so all of your labels have room to be on the right. Okay, here's the weird thing, and this is the thing that I got wrong every time I drew one. Where's the title supposed to go usually? Yeah, but it doesn't go there on these. Okay, the title goes underneath. I don't know why. That's just where it goes. Just do it. Doesn't make sense, but that's where it goes. Okay, the title goes underneath. Oh, plant cell or letter E or amoeba or whatever it is that you are looking at. And then the magnification under which you viewed it. So if you're looking at it on the high power lens, it would be 400x. If you're looking at it under the scanning lens, it would be 40x. And then lastly, the size. We talked about how to estimate the size of the object. Okay, so when you're looking at it under the microscope, okay, estimate the size of the object by determining how much of the space it takes up. Right? That is the proper format for a lab drawing. Labels all to one side, name, date, top right, title, magnification, size underneath. Question? All right, and that should be on each diagram. Each diagram should be 1 page, 1 full page in your lab report. Okay, don't try and fit them all on 1 page. We won't even waste paper here, handing this in electronically, right? So we don't even have to worry about saving trees. Okay, just make them big enough that each one is its own separate page in your lab report. Okay, that way they're nice and big. All right, so let's talk about how we build these in our lab report. Okay, so if I'm in my lab report, and I'll just pull that up here. Okay, so right here where it says see lab drawings on following pages. So I'm just going to go and make sure that my lab drawings are kind of on a new page. And I'm going to go to Insert. And I'm going to go to Drawing. Okay, Insert Drawing. Okay, that brings up Google Drawing. which is not a great program, but it's good enough for what we need. Okay, so once I have Google Drawing up, okay, I have a few options, not a lot, but a few. Okay, the first one is image. That's where I want to go to the file for the picture that I took. So when you're in the lab tomorrow and you're taking pictures with your phone through the microscope, make sure that you are sending those to your school email so that you can insert them into here. All right, so you'll need to send them to your school email and save them on your, or just upload them directly to your Google Drive, your school Google Drive. Okay, so I'm going to go click on image here, okay, and then I'll choose an image to upload. And all right, those are from last time I did this. Okay, maybe in pictures. Trying to think of where I have those pictures. Oh, here we go. Okay, so I've got a picture of an amoeba. All right, so imagine this was in your Google Drive and this was the picture of the amoeba that you took. So I'm just going to open that. Okay, so now it's in there. Now, this orientation is probably not all that practical for what I want because I want to be able to put labels off to one side. Okay, so I can rotate it, and I'll just rotate it clockwise. And then I'm just going to move it over. Okay, so now I've got that drawing there. I'll probably shrink it down so it actually fits in the checkered area. Okay, now I've got that. Now I need to use lines. Okay, so you see here it says line, and there's lots of different options. We just want a regular line. And I'll just start drawing lines as horizontal as possible, okay, across to here where I can put in my labels. All right, so okay, that's where those checkered boxes are kind of nice because they tell me whether I'm fairly straight or not. All right, then I'm going to put in all of my text. Okay, so the first thing I'm going to do is go up here, okay, and I'm going to put in my name. So, and it is October 10th, 2018. Whoop, 2108. Whoa, we're in the future. Okay, and then I'll do the same thing, okay, at the end of all of my labels. All right, so I'm just going to put a text box at the end of my labels, okay, and obviously, we haven't taken the parts of the cell yet, so I wouldn't expect you to know all of them, okay? But we kind of just do our best here. Try and make sure the label is right on the end. Okay, and then one more for this one. Okay, so now I've got my diagram built. Okay, what do I have to put down below? I still haven't put in my title and my magnification and all that. So, okay. Okay, and you can just use a U to represent mu because it's a pain in the neck to find the symbol. So just use a U. It looks a lot like mu. Okay, so that's 350 micrometers. All right, so now my lab diagram is done. Okay, so now I want to download. So I just clicked on actions there, and I just want to make it an image that I can use easily. Okay, so I'm going to make it a JPEG. All right, it'll just download it down to here. Okay, save it in your Google Drive, and then you'll be good. Okay, so just you can say show in folder or whatever, and then move it to your Google Drive, and then you can insert it into your lab report. So I'm just going to say show in folder, right? Right, so it's in there with the others. Okay, so I'm just going to close that up, and then I'm going to, well, look at that, it even inserted it for me. I didn't have to do anything. Boom, it's done. Okay. I think they must have updated the program. It didn't used to do that. All right, so it's in there. right? It didn't take up the whole page, but I could easily make it do so simply by skewing it. Okay, so it takes up the whole page. All right, questions on how the lab diagram works? Okay, you can always come back to this podcast because I'm recording the whole thing, okay, on how that's going to work. So you just use insert drawing, make your drawing, and you're good. Okay, back to this. Okay, so that'll be your observations. Then you'll have your analysis. Okay, obviously you can't do your analysis until we've done the lab. Okay, but for question number 1, using what you saw under the microscope, the size, the orientation, general characteristics. Okay, for this question, the letter E will be your most important specimen, because really you don't know if the orientation of an amoeba or a paramecium has changed. They're too small to see, and they don't have a fixed shape you're familiar with. Okay, but the letter E does have a fixed shape you're familiar with, so you'll know whether it got flipped or not or whatever under the microscope. So those will be important things to talk about in that answer. Okay, the letter E looked like this, which means the following things happened. That means the microscope works like this. Okay. Number 2 is just asking you to describe and explain the steps you took to find and focus your paramecium. So be simple, okay? When I got the slide, I put the slide under the microscope. I moved it to scanning power, blah, blah, blah. Okay, walk me through the steps. Okay, and then for the third part, why do we add water to a wet mount? I'm going to talk about how we make a wet mount tomorrow before we go into the lab. Okay, it's simply the way we'll make the slide for the letter E. Okay, it's pretty simple, right? But it'll make more sense. That question will make more sense tomorrow when I go over that. Okay, then conclusion, remember, copy and paste your hypothesis based on your observations. Can you accept or reject it? And sources of error. Okay, evaluation is 2 sources of error and how to fix them. I would say probably one good source of error you could use for this lab anyway, it would be inexperience with the microscope. Okay, you have the rest of class. You can work on that a little bit, maybe get the pre-lab stuff done so that tomorrow we're all ready to go straight away into the lab. We'll have the whole class period to work and make sure we find everything. Okay, any questions on that?